Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Welcome to Lesson 16, more on modeling relationships with a line. So example 1 is calculating residuals. The curb weight of a car is the weight of the car without luggage or passengers. The table below shows the curb weights in hundreds of pounds and fuel efficiencies in miles per gallon of 5 compact cars. And here they are. So these would be our x's. And these would be our y's. Using a calculator, the least squares line for this data set was found to have the equation of this, where x is the curb weight in hundreds of pounds, which I've labeled, and y is the predicted fuel efficiency in miles per gallon. The scatter plot of this data is shown below, and the least squares line is shown on the graph. Okay, so it says you will calculate the residuals for the 5 points in the scatter plot. Before calculating the residuals, look at the scatter plot. Okay, so to make this easier, I am going to use the calculator, and I'm going to put these values in the calculator, and it'll just be quicker to find the residuals. And it's a good review to show how you get this from this. So I've got my calculator on, home screen's clear. Go to y equals, make sure that's clear. Make sure your plot 1 is on, and to do that you arrow up and hit enter and arrow back down. And then we're going to enter our data. So I'm going to start by pressing the stat button, and edit's already there, so I press enter. And my L1 are my x's. So now I'm just going to enter 25.33, 26.94. Oops, I can't hit the backspace button on, I have to do that. Okay, 26.94, 27.79, 30.12, and 32.47. So there's my x's. Arrow over and put in the y's. 43, 38, 30, 34, and 30. That gives us, and remember if you go up to the last value, it'll tell you how many there are in the list, which is 5, and that's correct, and these must match or you'll get an error. So now I have my x's and my y's. So now I press stat, calculate, and we want a linear regression 4. And we want to make sure our x list comes from L1 and our y list is coming from L2. And you just enter through. And there is our slope and there's our y-intercept. So that is the graph of this line. So now if I go to y equals, this is the cut paste portion. To cut and paste, instead of Control C, Control V, which we can't do with this, we hit vars. We're doing statistics, so it's 5. We arrow to the right to EQ, and regression equations number 1. Hit enter, and it puts all that data into a linear equation under y1. This arrow here just means it continues, and it does not round, so it's very accurate. Then I'm going to zoom statistics, which is zoom 9, and as you can see, my graph matches this graph. Okay. So that's how they created this. So I'm going to work with my calculator from now on instead of this. So what they're asking us to do is to find the residuals. And what the residuals are from the last lesson is the difference between the predicted and the actual. So the dots are our actual, and the point that they would locate on that line are our predicted. And the little green distances I'm drawing here are your lengths of residual. If the dot is below the line, your residual is negative, and if the dot's above, your residual is positive. Okay, so we're going to take and find the lengths of all these points. That's what it means to calculate the residuals. Okay, page 2 brings us to the exercises. So number 1 says, with the residual for the car whose curb weight was 25.33 100 pounds be positive or negative? Okay, will the residual be positive or negative? So the 25.33 is looking at, we'll keep going back here, curve weight 25.33 is this point right here. Well, this point is above our prediction line, so the residual will be positive. Okay, so it's positive. Residual of 3 miles per gallon. The actual value is approximately 3 units above the line. So if we look, the predicted is 40, and the residual looks like about 43, halfway between 42 and 44. We're just approximating, so it's about 3. Okay, number 2. Will the residual for the car whose curb weight is 27.79 pounds be positive or negative? And roughly, what is the value of the residual for this point? So 27.79, going back to here, is 27.79 is just shy of 28. It is right here. It is below the line, so it will be negative. And its exact actual value is 30, or I should say approximate, but it is actual. It's 30. 32, or that's 28, 27.79 is 30, and its predicted looks to be about 36, so the residual will be negative 6. So there it is, negative residual of negative 6 miles per gallon. The actual value is 6 units below the line. Okay. The residuals for both of these curb weights are calculated as follows. Substitute x equals 25.33 into the equation of the least squares line to find the predicted fuel efficiency. So that's why I put this in my calculator. I can now go to my table in that second graph, and I forgot to delete all these, so let me just do that. Okay, and we want to put 25.33 in. So once this is in our calculator, we don't have to do the manual substitution, and you have to use your calculator anyway unless you want to do really long multiplication and round. So it came out to be 39.893, which is 39.9. Okay, so that was plugging in the actual. Now to calculate the residual is actual minus predicted. So actual was 43. This is our prediction line. 43 miles per gallon minus 39. So we're talking about this value right here. Let me switch to my pen. So if I go back to the table on the previous page, 25.33, the actual was 43. The predicted was 39.9. So that's what we're talking about here, 43 and 39.9. So we're taking the value from the table, subtracting the value we get when we plug the x into our least squares line, and that will be 43 minus 39.9, which comes out to be 3.1 miles per gallon residual, and it's positive because the point was above the line. And then it says substitute x equals 27.79. Now we're looking at this one. Actual fuel efficiency was 30, and when we plug 27.79 in our calculator, 0.79, enter, we got 36.1. So 36.1 is right here. Now calculate the residual. The actual is 30. 30, residual is actual y value minus predicted y value. Actual 30 minus 36.1 gives us a negative 6.1. Okay, so these two residuals have been written in the table below. Okay, page 3 brings us to exercise 3 and 4. And it says to continue to think about the car weights and fuel efficiency from example 1, calculate the remaining 3 residuals and write them in the table. So I'm going to bring that table in here. Okay, and there it is, magically appearing. Okay, so now we're going to do the rest of them. So what do we have to do? We already have actual. We need predicted. Okay, so we're going to put 26.94 over here. So 26.94, enter, and get 37.4. Okay, so 37.4, remember actual is here, this is actual. And these over here are predicted, and residual equals actual minus predicted. So this is going to be 38 minus predicted 37.4. We're rounding to 1 decimal place. So when I do this and borrow from the ones, I get 10 minus 4 is 0.6. So it's 0.6. Okay? All right, so now we're going to do 30.12. So 30.12, enter. There's our actual. There's our actual. There's our predicted. So it's going to be 34.0 minus 32.6. Okay, 3, 10, 4, 1.4. Okay, this is really pretty easy once you do a few of them. And then finally 32.47, we're going to get our predicted. 32.47 will be our predicted value of 28.97 rounds to 29. So it's going to be 30 actual minus predicted, which gives us a value of 1.0. Okay, so there's the table finished. That's number 3. Number 4 says, suppose that a car had a curb weight of 3,100 pounds. What does the least squares line predict for the fuel efficiency of this car? So if we were going to do this manually, the equation was y equals 78.62 minus 1.5290. And I am getting that from right here. And then you use, instead of the parentheses with that number, that is your x. So here's the equation that we're using. So we'd substitute 31 in here, multiply 31 times that, and subtract it from 78.62. I can very easily do that in my calculator over here by just hitting 31, enter. How fun is that? So our y, and this is more accurate because it's not rounding as much. So this is 31.223, but if we're going to round now, it's going to be 31, and that should not be an equal sign because I am rounding. It should be an approximation. So this is our approximation symbol, 31.2 mpg. Okay, part B says, would you be surprised if the actual fuel efficiency of this car was 29 miles per gallon, and explain your answer? Okay, so what they're saying is, look at the residuals. The maximum residual was 6.1, if you're thinking of absolute values. 6.1 is our largest absolute value number. 3.1, 0.0, or 0.6, 1.4, and 1.0. Well, what they're asking is if 29, so if we took the actual 29 and subtract our predicted of 31.2, and 10 minus 2 is 8, 8 minus 1 is 7, that would be a residual, I'm sorry, is that right? 31.2, 29? I'm doing that wrong. If we're subtracting, it's going to be 31.2 minus 29, and 2 minus 0 is 2, 3, 2, 1, 11, 10, 2.2, but since we're going backwards, it'd be a negative 2.2. Okay. So, miles per gallon is our residual on this. Is that out of the normal? And I would say no. We have a 3.1, we have a 6.1, negative 2.2 is less than our large two of them, so that would be okay. So putting that into words, I would say no, the residual for this point would be 29 miles per gallon minus 31.2 miles per gallon, or negative 2.2 miles per gallon. This is within the range of the residuals for the table above. Okay, there were values greater or less than that. All right, example 2. Making a residual plot to evaluate a line. It is often useful to make a graph of the residuals, called a residual plot. Okay, so this is new. You'll make the residual plot for the compact car data set. Plot the original x variable, curb weight in this case, on the horizontal axis, and the residuals on the vertical axis. For this example, you need to draw a horizontal axis that goes from 25 to 32, and a vertical axis with a scale that includes the values of the residuals that you calculated. Next, plot the point for the first car. The curb weight of the first car is 25.33 pounds, and the residual is 3.1 miles per gallon, so you plot the point 25.33, 3.1. Okay, page 4 brings us to the graph that they gave us, and they plotted the first point for us that they gave us as well, and that was the point 25.33 comma 3.1. So here's 25.33 up 3.1. So notice you have to have positive and negatives, and the points below would tell us that the residual or the actual value was below the predicted, and the points above would be above. So let's see, let's look at that. 25.33 comma 3.1. Going way back to here, 25.33 comma 3.1. So this was above. So if our y is above the predicted line, go back to here, then it will be above our residual line of 0. Does that make sense? Okay, so now I'm going to paste in the table so we don't have to keep going back and forth, and there's the values entered that we calculated. So now we're going to plot the rest of these. So let me get the pen, make it red. Okay, so here's the residual. So there's 25.33 comma 3.1. We're plotting curve weight as our x and residual as our y. So we want to go out to 26.94, which isn't quite 27, and go to 0.6, which is a little more than halfway up to 1. So this point would be right there. All right, 27.79 is just before 28. 27.5 would be here, so a little more than 3/4 of the way over is 27.79. And we want to go down negative 6.1. So that would be way down here, right there, approximately. And then finally 30.12 is just a little bit more than 30, and we're going up to 1.4, which is almost halfway between, whoops, let me try that again. Halfway, very difficult to do a dot with this pen. Okay, there you go, somewhere around there. And then finally 32.47 is the last one, which is about 32.5. Not quite the middle here. And then we're going up to 1. So I'd say right about there. So there is the plot of our residuals. Okay, so that was exercise 5. Plot the other 4 residuals, and the residual plot started in example 3. So there's 1, 2, 3, 4. We're done. Number 5. Number 6 says, how does the pattern of the points in the residual plot relate to the pattern of the original scatter plot? Looking at the original scatter plot, could you have known what the pattern of the residual plot would be? So the easiest way for me to do that would be to turn my calculator back on and go to graph. Okay, so there's our original, right? It matches this without those residual lines. Okay, it's the same graph as here. So can we compare this? Does it look similar to this? It kind of looks the same, except this line now is just rotated and it's flat. Doesn't that appear to be about the same? Okay. Okay, hold on to your hats. This is a long explanation. The first point in the scatter plot is quite a long, let's bring this down so we can see. So we'll go through this as the first point in the scatter plot is quite a long way above the least squares line. So it's up here. And as you can see, that was kind of above the, okay, that point's quite a bit above the least squares line, compared to the distances above or below the line of most of the other points. So it has a relatively large positive residual. Okay, so it's further than these 3 is what they're saying. The second point is a relatively small distance above the line. It's actually almost on the line, and therefore it's very close. So it has a small positive residual. The third point is a long way below the line, so it has a large negative residual. Okay, so this is way down here because it's further from this line here. The fourth point, this one here, is somewhat small distance above the line, so it has a somewhat small positive residual. Likewise, the fifth point has a relatively small residual, so it would have expected to have the 4 points above this. Okay, looking at the original scatter plot. Okay, likewise, the fifth point has a relatively small positive residual. Looking at the original scatter plot right here, there were 4 points above the least squares line and only 1 point below it. So I would have expected to have 4 points above the 0 line in the residual plot and only 1 below. Since the points above the line in the original scatter plot were closer to the line than the 1 point below it, I would have expected the point above the 0 line in the residual plot to be closer to the 0 line than the 1 point below. But I would actually add to that and say, well, if I just rotated this 90 degrees, let me do that. Okay, so I took a screenshot of this. So what I'm saying is if I rotate that, doesn't that look similar to my residual graph? Flatten this line. So it's basically taking this graph and rotating it so that your least squares line is horizontal, slope of 0 or rate of change of 0, and the residual points, or the residual graph, looks very similar to the original graph after rotating that like that. Pretty cool. Page 5 brings us to the end of lesson 16. Review the lesson summary and go to your problem set.